So, yes, I'm displaying stuff, your stuff, so that's not good. Sorry. I would just like to copy the list on the desktop. Excellent. Yeah. Thanks a lot. Okay, hello everyone. Welcome to Bess. We'll try to start right now because we have a pretty packed agenda today. I'm alone to chair this meeting. My co-chair is not here. So don't be surprised, but he may show up on the Jabber room. So I would like to ask first if someone would be ready to join into the Jabber room and channel my co-chair's comment. Would somebody be available to do this? That would be helpful. Thank you very much. Okay, so let's start. And I want to say thank you to Anshu Verma, who very kindly let me use her laptop to display the slides because I had some technical issues here. So thank you very much. The notebook is something that you, I guess, know already. You need to be aware of all this when you do IETF submissions. So please read the slide carefully. They're posted on the in the proceedings, or read the documents. So we need to have the blue sheets. So we also would like to have minute takers. Would somebody or maybe multiple somebodies would be ready to take the minutes? Usually people are volunteer. We have too many, but maybe today we would have just one. Okay. Okay, we'll try to do without. But if somebody take notes, it would be useful if they share them. The Etherpad can be useful for this. So since last IETF, we had two RFCs published. We had the 2 document passing working group last call, and we have another one which will be closed soon. And we adopted 7 new documents. So we can say that the working group is kicking and alive with still a lot of activity. So 2 words on recent calls. We had a working group last call going on the EVPN overlay draft over the last, well, at the end of June. We are waiting for a respin from the authors to address the pending comments and include the changes that they agreed to. So as chairs, we found that it was actually not ideal to not have more feedback at the working group last call step, because it's an important draft. We would go as far as to say that it's a cornerstone draft on which many other drafts are depending, and which is now heavily deployed in the industry. So we will proceed on this draft. Well, we still need to have the last reviews on the future respin, but we will proceed, and we will try to complement reviews to have more reviews than what we've currently had. Next topic is the call for adoption of the VXLAN EVPN draft. So we consider that we have a too small support base to adopt this draft now. So we will consider doing a call for adoption again when and if we hear more about the actual needs for such a solution. So that's the current conclusion after the call for adoption. But we are ready to hear typically feedback on actual needs. Currently, we haven't heard about any operator or people wanting to deploy this. So we have a lot of expired documents. The key thing here is to determine if there is motivation to move them on. So if you are motivated to see this draft move on, so step up, talk to us, and it will help. And if not, these documents may become abandoned along the road. We have one document in particular, which is in a particular state. It's the end system LTVPN draft. It had been submitted for the first time to the ISG nearly 2 years ago. And there is really a lack of thrust to address the IETF review comments. And actually, the initial editor of this draft has exposed his wish to step down as to hand over editorship. So a few weeks ago, our AD, Alvaro, returned the document to the working group for these very good reasons. It was actually the second time he did so. Currently, we haven't yet identified a co-author ready to take the job, even among the co-authors. So we have had discussion, but no conclusion. So people, and especially co-authors, need to be aware that if nobody steps up, the document will be abandoned. I mean, no active decision would be taken, but it will just not progress. So we are again willing to have comments on this to see what will be the next steps. Any comments from the co-authors of this draft in the room, or maybe, yeah, Ali?
I didn't see EVPN each reader, and that basically the working group last call has been completed. They review everything, and the latest draft has been published there. So it is ready for the chairs to
write. So yeah, the data tracker has all the list of the status of the various documents. Okay. There are different documents that are in the state waiting for shepherd reviews or during shepherd reviews. So I didn't specify the different state of each document because it's in the data tracker. but your document is among others is not forgotten.
Okay, so should we hope that is going to get pushed through before the next IETF?
Oh yeah, of course. So yes, it's in this list of the 5 documents that are post working group last call and waiting for write-ups or in IESG. So we plan to do working group last calls on these 2 documents, the inter-subnet forwarding draft and the virtual subnet fee reduction. We have well noted that the authors think that they are ready for working group last calls. And we also have these 3 planned calls for adoption that we will start sometime after this IETF. I can note that we actually have the L3VPN Yang draft in this list. We have, well, looking at the slides, we know that the hosters still need to do work on this draft, but we think it's still worth adopting now so that the work is done with all the working group, with the working group at the whole involved. So we won't wait until everything is finished before adopting, because we think that the working group should work on the document and not wait that the document is fully ready before adopting. So this is the agenda for today. And the first speaker is Enchu. Yes, let's do this. There's usually a... The mic is there. Yeah, use this one. Use the one you like.
Hello. Hi, everyone. I'm Anshu from Juniper Networks, and this is the Bess VPLS Best Site ID draft. So this draft explains, defines the protocol extension required for signaling the best site when BGP VPLS is used. Next slide, please. Okay. So before we go on, what we're trying to solve, let's take a minute and refresh our memory what the best site is and what the site ID was in VPLS. So with the BGP protocol, each CE device or a site is identified with a unique site identifier. Say for instance, if you have 3 Ps, P1, P2, P3, my P1 might have like a site ID 1 attached to it, P2 might have a site ID 2 attached to it, and P3 might have a site ID 3 attached to it. So we use this site ID for calculating the inner VPN label, and that gets signaled to the remote VPLS-PEs. So what happens here is you also associate the interface of the CE device along with your site identifier. So each VPLS-PE has a unique site identifier, but in case the 2 of the Ps are connected to the same CE device, they might have like a same site ID attached to it. So the exception is multi-homing in this case. The site IDs can be of 2 types. It can be like statically configured, or it can be dynamic using the auto site ID draft. When it's static, it's like provisioned through the CLI. Next slide, please. So what happens is on my VPLS-P, I might have like multiple CE devices or sites configured. So the VPLS-PE picks up the VPLS path selection algorithm, picks up the least site ID and uses as the most preferable site ID. So using this site ID, you program your the label block, and it gets advertised to the remote PEs. So what happens in this case is when I'm using this particular elected site ID, I establish a pseudo wire using this elected site ID. Whenever my attached circuit of this site ID goes down, I have to bring down the pseudo wire. So my and again on this PPLSPE, I'll again elect a new pseudo wire, elect a new site ID and establish a pseudo wire using the new elected site ID. So this disruption of once as soon as your access attached C device goes down, you bring down the pseudo wire, re-elect new one, and again create a new pseudo wire. This needs like a few CPO cycles, and also disrupts. It also needs like convergence. It impacts the convergence. So what Bess side brings in is whenever can you go on the next slide, please? Whenever you configure the Bess site on your PPLSPE, it acts as like a dummy site. You don't need an access interface or an actual minimum site ID configured in your needed for that. So this, say for instance, my VPLSPE might have like 1, 2, 3 on PE1, and PE2 might have 5, 6, 7 site IDs, and if you have configured Bess site on PE1, then you don't pick up the lowest one. It can be like any dummy. It's a dummy site ID. My Bess site can be like 100, but I will use this for bringing up my pseudo wire. I don't care about the minimum. I just use this regardless. It's not a minimum. I use this for bringing in my label in my label block for establishing a pseudo wire. So what this gives us is even though like it's not the minimum, it doesn't cause, even though it's not the minimum, it doesn't cause any traffic disruptions when any of the attached CE devices go up, like they go up, they go down. So there is no traffic disruption. I have a pseudo wire which remains always up regardless of any of the failures in the access side, and you don't have to recompute whenever my elected site goes down. So that is the advantages the Bess site ID gives us. What we use in Bess site ID is we use the control flags. We set the B bit in the control flag. If you go on the next slide. So we use the B bit in the control flags, and we signal the label block. So whenever a PE receives the label block with a B bit set, it honors this Bess site and honors this site ID as a Bess site, and will reuse for establishing a pseudo wire. And if the B bit is not set, it's going to use a legacy like site election mechanism for electing a site ID. In the next slide, you would see. Can you go on the next slide, please?
Sorry.
Yeah. So in this case, you would see that my PE3 is this example is only showing in terms of PE3. So PE3. All the P's are exchanging the BGP NLRIs. The P3 sends the label advertisement with B bit set, and all the other P's are also sending the label advertisement with the B bit set except P4. So when P3 receives the labels with the B bit set, it honors those sites as as the most preferred site, and uses them for establishing a pseudo wire. Except P4. So P4 is not setting like B bit, but it's signaling with the B bit set as 0. So it uses a legacy mechanism for selecting the best site in this case. So it is back. So this brings us a backward compatibility. If you're sending the label block with a dummy site with a B bit set, you use that. If you're not, then you use the legacy mechanism for electing the best site. The advantage we get for the best site is that whatever pseudo wires we have established from the ingress PE towards the remote P's, they always remain up. We don't disrupt them. So what additionally is required here is you need additional mechanism like a MAC flush mechanism for bringing down like the MAC plus pseudo wire bindings. In the next slide, along with the best side, we need like explicit MAC flush mechanism because the traffic might be black hole when you transition from DF to non-DF. So whenever the DF will send the best side, will advertise a label, it's going to set the F bit as well. It will set the F bit as 1, and if it's a non-DF and it's sending the label advertisement, it's going to set the F bit as 0. So whenever the remote Ps notice a transition from 1 to 0, they flush the MAC plus pseudowire bindings. So that's how you don't have any stale MACs pointing to the pseudowire, which doesn't even exist, and you don't get the traffic black holing. Any questions?
Jorge Rabadan, Nokia. So I think, I guess this is an existing solution, and it's good. It's very good to document, especially because you are using one of the bits in the L2X in the community. So it's good to have it finally documented. But all the challenges that you are talking about, I think they are already solved in the VPLS multi-homing draft. And in any case, you are referring to that draft for the McFlash and all that, right? So my question is, am I missing any advantage in this document compared to the VPLS multi-homing draft?
So if you don't have the VPLS multi-homing implementation, then you can still leverage this one for like your set preferring one of the dummy sites as a best site and bringing up a pseudowire, so it doesn't affect the my core pseudowire does not get affected by any of the access site failures.
Right, but would you agree that if you have a VPLS multi-homing implementation, basically you don't need to do this, right?
Yeah.
Okay, thanks.
Alice, Cisco. So you mentioned that this helps with the convergence. In either case, whether you withdraw the label or you signal it to do the MAC flushing, you're going to be doing this signaling over BGP.
Mm-hmm.
So how would it help with the convergence? Because you need to send that BGP message anyway.
So like in your if maybe the convergence in terms of if I was bringing for my access failures, if I was bringing down a pseudowire and again re-establishing a pseudowire, then that
would be in the noise compared to the the transmission time of that BGP signaling and all that.
Yeah.
Wim Hendricks, Nokia. If VPLS multi-homing is already a working group draft and it solves this problem, why do we need this? Is there a problem with VPLS multi-homing, why is it, you better implement that in my case than doing something else again, because we all have to do interoperability and stuff like that. So I believe it's much better to standardize upon VPLS multi-homing and have that as the baseline solution, because it's covering all the cases which are already in here.
We can actually take that offline, but again, if you don't have the implementation, then this can help there.
Okay, but if we standardize this, then we have to implement two things. So if VPLS multi-homing is already there, or if you need a solution in this space, implement VPLS multi-homing, and we'll have a common solution for all these cases, and this one is covered in there as well.
Yeah, I agree.
Jorge Rodan, Nokia. I fully agree with Wim. The only extra comment is that there are existing implementations and they are taking this bit that we cannot use in any other standard, right? So maybe a solution would be to standardize this as an informational document as opposed to a standard-based or standard track document, right?
Hi, this is Wen from Juniper. Yeah, I agree with Homie's comments. Informational will be the right way to go, because when you have a multi-homing as a best draft, it's essentially this procedure is not used. But this one actually, the mechanism was used before the multi-homing, the other best procedure. So the B bit was assigned, so informational will be good to go. Also to Ali's comments, this does improved convergence. The whole multi-homing draft also is based on the same concept. Basically, the label block is associated with the VPLS instance ID. It's never associated with any access interface. So the whole idea is the same. This does not withdraw because of access link to a CE device goes down. Then you have to tear down the pseudo wire and then reestablish. The whole one of the main idea about the multi-home Bess multi-home draft is the same.
But Patrice from Cisco, I think the only comment I have is if you really care about the convergence, maybe you should deal with multi-homing instead of singular homing.
Can you?
Okay, so I'm not sure everyone catch what you said, but can you send it on the list because we'll have to move on the agenda. So, thank you, Patrice. Robert, it's your turn. Thank you.
Hi, my name is Robert Kebler. I'll be talking about the update to the MVPN fast failover draft. Listed here are the editors, and we have 10 other co-authors, contributing co-authors. All right, so just a overview of the draft, or a repeat of what the draft is. There are procedures on the downstream PE and upstream PE. Normally, a downstream PE will send a C-multicast route to its primary UMH. In the case of these procedures, it will also send a standby C-multicast route to a backup UMH, a backup upstream PE. The secondary upstream PE can operate in 3 different modes: cold route standby, warm, and hot route standby. So as an example, in hot route standby, the secondary upstream PE will join back to the source, draw traffic to itself, and send traffic onto its provider tunnel. The traffic will reach the downstream PE on both the primary tunnel and the backup tunnel in a live fashion, and the downstream PE will send a single stream along to its receivers. The downstream PE will detect that there's a failure on the primary tunnel by monitoring the tunnel status, and upon a failure, it will start sending from the backup tunnel to the receiver as a fast failover solution. Next slide. Okay, so there are some changes in this last revision, in the 01 revision. Some of them were minor clarifications, making some of the naming conventions consistent. So some of the larger changes were, we updated the description of the PECE link protection. This is a method where the upstream PE can protect its PECE link by advertising an SPMSI AD route with a BFD discriminator corresponding with the protected PECE link. Where that protected link that is being protected is the RPF interface towards the particular source or RP. The BFD session is created, and upon any PECE link failure, the upstream PE can bring down the BFD session, which is an indication to the downstream PE that there was some failure along the path to the source, and the downstream PE can use that information to switch over to the backup tunnel. Also, we added some text around revertive behavior. This is the case where you have a primary UMH that goes down. When that happens, or the primary tunnel goes down, the downstream PE will switch to the backup tunnel and start forwarding on that. Now, when the primary tunnel comes back up, we specify that the downstream PE should switch back to forwarding from the primary tunnel again. This is the revertive behavior. This makes it deterministic and more consistent from the downstream PEs from a given time which upstream PE they'll be choosing. And it helps in especially cases like warm route standby.
Greg Mirsky, Ericsson. So when you say the BFD session would be brought down, what that exactly means?
Oh, in the case of the the upstream PE there is a multi-point BFD session between the upstream PE and the downstream PE, and the the BFD session can be brought down. Are you saying that?
No, but what you mean by bringing down the BFD session? Are you stopping sending BFD packets? Are you putting some code in a BFD state like admin down or something?
It would be using the existing method, which mechanism,
But
which
there
would
is
be
no
stop sending, say, keep alives.
But, okay, can you be specific about it? How
Okay.
you do it? What are you proposing? What you mean by bring down the BFD session?
Okay,
Especially,
presumably,
especially since if you are talking about BFD for multi-point networks, this is only the working group document. It's not a standard yet. So I'm just very curious about what you mean by bringing down the multi-point. If you are using active tails, that's a different story. But multi-point is unidirectional, and you will affect all the PEs. You cannot bring one of the leaves down.
No, but we are talking about bringing the whole session down, but not one of the leaves.
But how?
Yeah,
Because again, another thing is that what the bootstrapping mechanism you use, because the current document does not define the bootstrapping mechanism for point to multi-point BFD session. So how you bootstrap? And that means raises the question how you do the revertive behavior, because how you revert this BFD session up again if you don't have a bootstrapping mechanism.
so the bootstrapping mechanism is by sending the BFD discriminator in the BGP messages.
That is not defined in a BFD document.
It's defined in this document.
Then it needs to be you need to bring this to BFD working group. Because if you're proposing some mechanism to bootstrap BFD session, I would, at least for FYI, bring it to BFD group.
Okay, so fair enough. You've raised a couple questions. We can try to make the draft a little bit more clear as far as how the BFD session will be brought down. If it stops sending the keep alives, we can try to clarify. And we did merge with a document that specifies some sending the BFD discriminator in these BGP messages. And fair enough, that will probably be reviewed within the BFD working group.
Right, because as far as I know, currently for point-to-point BFD session over LSP, there's standard procedures to use LSP ping BFD discriminator sub TOV with a target FAC.
Okay, thank you.
Okay, so the next steps, we just there's a lot of different options in this draft. The thought is we should try to be a little clearer on exactly what needs to be implemented to say that this draft is being supported. Some of the options are given in the draft as determining the tunnel status, what would be needed there. There are options of hot, warm, and cold route standby. Some of the leaf PE procedures of sending the standby C multicast route. So if folks have any comments, opinions on this, please let us know. We hope to have another draft out, hopefully clarifying some of this. And please review and send comments on the latest rev.
Thank you, Ben. Comments? Yes, Jeffrey, I think it's, let me check. Yes. Doesn't work. I don't know why, but it's...
Okay, I'm going to talk about some enhancements proposals for MVP and C multicast routes. We have four co-authors from Juniper, me, Bob, Wenling, and Eric Rosen. I'll just dive into MPLS C multicast routes now. MVP and C multicast routes are used to disseminate customer multicast state across the provider core. For example, when you get a PIM join on a PEC interface, how do you carry that state over the core to the upstream or ingress PE? With MVP and C multicast, MVPN, in most situations, those C multicast routes are targeted at the ingress PE, except in one scenario, which I will talk about later. In that target scenario, the RD of the simulcast routes is the RD of the VRF on the ingress PE, and route targets also make sure that only the VRF on the ingress PE will import the routes. There are some issues in the RFC 6513 and 6514 about the simulcast routes. In particular, the inter-ES propagation, and in that special scenario to support pin binder. Additionally, if we are using the selective tunnels to support pin binder using the MAPIN RPL method, then the procedures could be further optimized. So this draft talks about those issues and the proposed updates. Next slide. Next slide. So one more. So basically, I'm skipping 2 slides here that talks about inter-ES propagation issues and proposals, given that I don't have much time here. So now I'm jumping to the pin binder support with MAPN. First, a quick recap on the pin binder concept. I have an example topology here on the right side. We have 6 routers here, and at the top, R1, 2, 3 are connected to this RP link, and on which there is a rendezvous point address that does not necessarily belong to any physical router. So router 5 and 6 have receivers for a particular group G. So they will send pin binder joins towards the RPA, establishing a tree rooted at the RPA with the branches anchor off at the R2 and R3 on the RPL. And the source is connected to R4. The traffic will follow will be sent upstream towards the RPL and gets dumped to the RPL by R1 and picked up by R2 and R3, and then forwarded along the bidirectional tree towards receiver 1 and receiver 2. That's basically how it works in a pin binder. Notice that with pin binder, the DF election is required on the network, so that only certain routers are allowed to forward traffic to avoid traffic loops and duplications. Now, that's how plain pin binder works. Now, if you combine it with MVPN, there are two ways to do it. One way is that we make the VPN backbone as that RPL itself. Here I use the C binder. C binder basically means the customer pin binder in this context. So when we make the VPN backbone as the RPL, we call this method as MVPN-RPL. The advantage of this method is that we can avoid the DF election over this provider core, which basically serves as a virtual LAN here. So that's MVPN-RPL method. Next slide, please. So similarly to the regular pin binder, when the PE receive traffic on the PEC interface, needs to be sent across the backbone, which is RPL, if and only if another PE also has corresponding state for that particular group. And that is indicated by the existence of C-multicast routes that other PEs originates. Here, those C-multicast routes are no longer targeted at a particular ingress PE. Instead, it's targeted for everyone and distributed to all PEs. By default, the RPL is instantiated by inclusive tunnel. So as long as you have one PE that needs to receive traffic, then every PE gets it. You could also use selective tunnel, and currently MVPN procedure for selective tunnel requires using SPNZ AD routes for all tunnel types to announce the tunnel to use. And if you're using the RCP tunnel, ingress replication tunnel, or beer tunnel, then you also need to have leaf AD routes. Here, the PIMZ stands for Provider Multicast Service Interface. It's a conceptual interface that the PE uses to send traffic to other PEs. So basically, an ingress PE that picks up traffic that needs to send it across the core will originate that SPNZ routes indicating that this is the flow I'm going to send, and this is the tunnel I'm going to use. And then if a PE egress PE needs to receive the traffic, then it need to send leaf AD routes if the tunnel is RCP or IR or beer. Notice that here the leaf AD routes basically serves the purpose of explicit tracking, tell the ingress PE which egress PE needs to receive traffic. Now, if all the routers could be sending traffic and all routers could be may need to receive traffic, then we get a full mesh. We need to advertise n SPNG AD routes and the n square of leaf AD routes in the worst situation. Next slide, please. So the optimizations here is that if you use an RCP or ingress verification or beer, there's really no need for the leaf AD routes here, because C-multicast routes here, they can already serve the purpose of explicit tracking. Each have their own RDs and so the route reflector will not aggregate them. So from the C-multicast route, you know exactly which routers need to receive traffic. So here, those C-multicast routes are no longer targeted, and it serves explicit tracking purposes. And in case of ingress replication and beer, you don't need to add the SPNG route to announce the tunnel either. It's the ingress replication or beer. There's no tunnel to announce. On the other hand, if you are using PIM or MLDP tunnel, then you do not need the explicit tracking. So now, when you advertise the C-multicast routes for MVPN, you do not want to use your individual RDs. Instead, you could use a common RD that is specific for that particular VPN. That way, the route reflector in the middle will only reflect some of the paths, so that let's say you have 100 Ps in your network. They all advertise the same C-multicast route using the same ID. Then the ingress PE only need to keep 1 or 2 copies of that route instead of 100 copies. There is one small gotcha here. That's to use this, we need to use the BGP add pass feature. The reason for that is detailed in the draft itself. It will take some time to explain, so I'm going to skip that. Next slide, please. Now, EVPN, well, what's the how it's involved here? A EVPN bridge domain basically simulates a LAN. On that LAN, you could have hosts sending multicast traffic for certain groups. You could have some hosts interested in receiving traffic for some groups, and that's indicated by the IGMP or MLD protocol, the signal interest. In this diagram, I have 4 PEs. I'm only depicting one particular bridge domain. We have receivers on PE 2, 3, 4, and source on PE1 for this particular group G1. So draft suggests Bess EVP IGMP MD proxy draft talks about how we can do the effective forwarding and also suppress the IGMP refresh message across the core. Basically, a PE does the IGMP snooping on the so it knows that whether there are any receivers on some PEC interfaces, and then in the meantime it also generates those corresponding selective multicast Ethernet tag routes, we call it SMAN routes, across the core, so that the upstream PE can turn that back into IGMP messages. Here, those SMAC routes are sent to all other PEs because the senders could be everywhere. Other PEs won't send traffic to this PE unless you have received corresponding SMAC routes. Notice that here, EVPN SMAC routes is very similar to the untargeted explicit tracking MVPN C-multicast routes we talked about earlier. The draft suggests assumes ingress verification or beer in the tunnel in the core. In that case, indeed, there is no need for the SPNG or FAD routes procedures, and that's indeed how the draft specifies already. And then if you're using PIM tunnel or MLDP tunnel or RCP tunnel, then as for selective tunnels, then the same optimization that we talked about earlier for MVP and RPL could also be applied here. So this is just a small, basically this shows that how similar the two are. And then the some optimizations that we talked about earlier is either already the specified procedure or could be applied here, depending on what kind of tunnel types are. Next slide, please. So next big topic covered by the draft is provider tunnel segmentation. This also applies to both MVPN and EVPN. Provider tunnel segmentation is often used to allow different tunnel types in different AS for either for admin reason or for technical reason. And it also allows to aggregate many individual PE to PE tunnels to AS level. So you no longer have individual PE to PE tunnels across your inter-AS link. Instead, you just have the tunnels at AS level. That also restricts those per PE PIMZ leaf AD routes to the same AS, and you only have the per AS tunnels and corresponding routes on the inter-AS links. That segmentation is achieved by the PIMZ leaf AD route procedures that is already specified for MVPN in the MVPN RFCs, and then we also have drafts that extending the same concept to EVPN. Now, because untargeted explicit tracking C-multicast routes removes the need of PIMZ and leaf AD routes, then that brings some challenges to the segmentation that previously depends on the PIMZ and leaf AD routes. So how do we solve this problem for both MVPN and EVPN? Next slide, please. So let's look at the challenges first. Route aggregation and propagation. Here I have three ASs. In each AS I have 100 PEs. In AS1, all those 100 PEs originates the C-multicast routes or SMAT routes. Now, ASBR1, we would want the ASBR1 to aggregate this into a single one instead of propagating everyone into other ASs. That's that the red arrow means. Next, can you click? Yeah. So now in AS2, those 100 PEs, they could also have their own local receivers, so they will advertise 100 C-multicast routes. Again, the ASBR2 will suppress those. They will advertise one single route and propagate to ASBR1 and ASBR3. Next. Notice that the one from ASBR1 propagate to ASBR2, we would not want the ASBR2 to propagate further to ASBR3. And because that one should be absorbed into the one that ASBR2 originated by itself. Next. Now, if there is a direct connection between ASBR1 and ASBR3, the question is, should ASBR3 propagate that route that it received from ASBR2 to ASBR1? Next. Yeah. If that route is sent, then ASBR3 will get traffic from ASBR1 directly, and then it may send it to ASBR2. Now ASBR2 gets two copies, duplication. Click again. Now, if you don't send it, and then if the ASBR1 and ASBR2 link, the link between ASBR1 and 2 goes down, how do you get traffic? So all those kind of dynamics, we need to handle it. Click again. The second challenge is traffic forwarding. Multicast traffic forwarding must follow routed trees, at least in the non-bear case. Without segmentation, it's simple. The trees are routed at each individual PEs, and with the leaves being all other PEs that need to receive traffic. With the segmentation, using the inter-AS example, we will have inter-AS trees, they're rooted at the source AS, with branches of the tree be beginning with the ASPRs in the source ES and extending to other ASPRs along the way. Can you click? Yeah. One example here is that we have the 3 ASs with 300 Ps. They all need to receive star G1 traffic. Click again. Now, traffic from AS1, it could be that sent by ASPR1 sent to ASPR2 and 3, and then those two ASPRs, ASPR2 and 3, they should not send to each other further. Next. And traffic originating from AS2 could follow a different path. It's sent to the ASPR1 first and then sent to ASPR3, but then ASPR3 should not send it back to ASPR2. Next. Similarly, traffic from AS3 could be sent to ASPR2 first and then to ASPR1, but ASPR1 should not send it back to ASPR3. Next. All this can be handled very well by the PNG and leaf-AD procedure that is already specified in the RFC 6514 and extended to EVPN by the draft-down Bess EVPN bound procedure updates. Next slide, please. Now, if we come to this early example of MVPN RPL and EVPN SMAN routes, we no longer, because those CMODcast routes or SMAN routes, they will replace the SPNZ and leaf-AD route procedure. That is no longer there. Then how do we handle the segmentation here? The proposal here is that ASPRs will turn those untargeted explicit tracking CMODcast routes or SMAN routes into targeted leaf-AD routes. So the PEs will behave as normal. They will advertise untargeted explicit tracking CMODcast routes or SMAN routes if they have the local receivers. And then the ASPRs in the local ES, when they receive those routes, they do not propagate those routes further. Instead, they pretend that they have received the corresponding SPNZ routes from some ASPRs in each remote AES. That SPNZ route is imagined, is fabricated. How it is fabricated, if we take a look at the EVPN, I should say SMAT route here. You have a RD, Ethernet tag, and then source group information originating our router's IP address. The RD and our Ethernet tag could be from that the per AS IPMZ routes that was discussed in that EVPN bound procedure update draft. And then the source group information are from the received CMODcast or SMAT routes. So now we have fabricated these SPNZ routes, and then we can use that to generate the corresponding leaf-AD routes, and that will allow us build the inter-AS trees rooted at each AS. And again, just like the existing segmentation procedure, you can use different tunnel types in different ASs. Next slide, please.
You need to
yes
accelerate a bit.
Yeah. So this is actually my last slide, some example trees. Can you click? Examples, I have 5 ASs. We'll build 5 trees rooted at different ASs. For AS1, the tree could be going through AS2 and AS5. The receivers are only AS3 and AS5. And then click again. For the tree rooted at AS2, it goes through, it's different, and then so on and so forth. You can just click through. So summary. So MVP CMODcast routes, we have some issues in the existing specification. the draft updates those procedures, and then we also propose some optimizations for selective tunnels in case of MVP and RPL method. And EVP estimate routes are very similar. The above-mentioned optimizations for MVP and RPL, they are either already the specified behavior for the EVP and estimate routes, or they could be applied to EVP and estimate routes as well. And then finally, we propose a common segmentation procedures for both MVP and RPL method, and then for EVP and estimate routes. That's my presentation. Yeah.
Thank you. Comments?
Yeah, question. If you go back to the
Louder, please.
If you go back to the previous slide, please. No, one more. I'm wondering, instead of when we go between the different ASS, instead of defining a new route, can't you use the estimate route and summarize using estimate route, because all the fields are available in the estimate route, and you can use the extended community to indicate that it is coming from the ASPR?
We looked into that, then that's not good enough. We can talk about it offline.
Okay.
And the reason I gave example of those challenges is exactly trying to explain why, at least so far, why we see we need to rely on the PNG and FAD procedures. So,
No, I'm saying the procedures, I agree with the procedures, that we should have the procedures. But the route to be used for the procedures, instead of using a new route, you can leverage the existing route with the indication.
Okay.
But we can,
Yeah, we can talk offline.
Okay.
Yeah, thanks.
Other comments? Okay, thank you. Next speaker is you, Ali. Has everyone signed the blue sheets? Who has not?
my name is Ali Sajasi at Cisco, and to make up for Jeffrey Long presentation, I'm making my presentation very short.
So you will have time for lots of comments. Oh,
Yeah.
not that much, we are late.
Plenty of time. So this is basically just to give you an update with respect to what's going on with this draft. And with the single homing, what we have in the draft works fine. And however, when we talk about the multi-homing and all active multi-homing specifically, we run into some challenges. And this prezo is a short prezo, is to capture what those challenges are. It doesn't talk about the solution. The solution is still at work. And hopefully before the next IETF, we should have it ready. So couple of other points. These issues have been in discussion among multiple vendors, and we are currently entertaining several options, which way to go. Next slide, please. So the issue is with multi-homing all active, and by all active multi-homing, I'm talking about the Ether channel. Okay, when you use a Ether channel or LACP, connecting it to the multiple PEs. And when we talk about IGMP and the join and the leave and those messages, you're talking about the all active, it can be received on any link. So these messages can get hashed to any link on that Ether channel. And the question becomes is, how are we gonna synchronize the IGMP states and among the PEs participating in that redundancy group. Next slide, please. So to give you an example with respect to the some of these challenges, let's look at the join. Okay, we are in here. We have CE2 multi-home to PE1, 2, and 3, and PE2 is the DF for that ether channel. So what that means the traffic that comes from the source, if we assume is sitting behind the PE4, and the traffic that gets sent from PE4 toward this ether segment, we want it to go to the DFPE. So we want the PE2 join that tunnel. And we don't want PE1 and PE2 receive that if they're not DF, because if it just wastes the bandwidth to get the traffic and drop it. So we want the traffic, PE2 is a DF, and PE2 we want to get the traffic, but the joins gets received by PE1 and PE3, and PE2 doesn't receive any join for that multicast group. So we need to somehow sync the state and let the PE2 know that there is a host interested in that multicast group. That is one. Next slide, please. The other challenge, so this is a previous slide was with respect to the challenges for syncing the join. Now this is the challenges for syncing the leave. So the leave comes, again, same example, PE2 is the designated forwarder for that VLAN. And the leave comes, CE2 sends a leave to PE3. And in IGMP v2, when the router gets the leave, they go into the expedited timing procedure, and it starts, it sends a last member query, and it starts, instead of a 60-second timer, goes to a 1-second timer. So it sends the LMQ, last member query, and here is the interesting part. CE2 sends the, there is a host in there, so somebody is going to respond, and a host is going to respond, say, you know, I'm still here, but that the join from the host can end up on PE1. So the LMQ gets sent from PE3, the timer is getting started on PE3, PE1 receives the join, and PE2 is the one that needs to know about it, because PE2 is the decision maker to whether to disengage itself from the multicast tunnel or not. So now the question is, how are you going to sync up this LMQ procedure among these PEs? Next slide, please. So if we break the, if we break what we need to do into the different items, one of it is ensuring that only one PE gets the traffic that has a multicast group interested in. And that means multiple options. You know, there are few options in here. One is the baseline approach we do for the designated forwarder per VLAN. One is we can do designated forwarder per multicast group, and then the third approach use the Anycast. And with the Anycast PE address, you send only one copy to that group. These have you know, they have their own trade-offs, but it shouldn't be the solution for this. Shouldn't be considered in isolation to say, okay, for this functionality, I'm going to pick the best approach is this. interestingly enough, you pick one approach in here, it not necessarily works for to address the best approach to address the other stuff. So we need to have a solution that look at the whole problem space in totality and tries to optimize it across the whole thing. So next slide, please. With respect to join sync and syncing IGMP states among the PE, we can define a new EVPN routes to do the IGMP join sync and to do the LMQ, LMQ indication, or we can use attribute, or we can use a combination of the both. The initial join message that comes from the IGMP, without getting, let me not get into the too much details in here, and just mention that the final solution might be a combination of different routes and attribute, and not necessarily one or the other, because we want to make sure we don't use the BGP to indicate events, and every message that comes, we generate one message in BGP. That's not what the BGP is for, but to cache the state transition. Next slide. So this is just to give you guys a heads up, what are the challenges and what we've been doing. We've been discussing this, I've been discussing this extensively, especially with John Drake, for quite a while. And other parties are involved now, and we are trying to hash it out and come with a common solution to address this problem. So by next IETF, I would say there's going to be a proposal and a appraisal on the solution. Question?
Thank you, Eddie.
Go ahead, please.
Yeah,
Jorge.
Jorge Rabadan, Nokia. Just one comment. So you mentioned at the beginning that all these procedures were for all active multi-homing, but we should use them also for single active multi-homing in order to speed up convergence.
I agree. I agree.
It would suck.
Yes, it applies there as well. Good point. Question, comments? Okay, Jeffrey, I made up for you.
Well, you did your 10 times last.
It was 10 minutes
10 minutes.
really? I thought I did
Well,
it in 8.
No, you had 10 and you did 10. That was great.
Okay.
Thank you. Patrice, please.
All right, I'm Patrice from Cisco. So I'm here to give you a quick update about Yang. And so for L2, EVPN, and L3. So I will not take my 10 minutes, Thomas. So next one. So let's start with L2 VPN. So there's been a lot of discussion, and I think a lot of progress has been made, especially in terms that we brought the opera data as part of the model. And then we get the workgroup adoption also, like since we met from Argentina, and as soon as we get workgroup adoption, a lot of good comments and people jump into this draft and start reading it. So I will say to people, wait before trying to implement that. We are going through some rework, especially on the flow, like the layout of the Yang model itself. I don't think we didn't get any, I think, problems on the details and the attributes and the way we how can I say that? We declare the each angle end block, like for the interface, how the subparameters and so on. So that I think has gelled. but more the layout of the Yang itself. So that's the major part we are planning to do very soon. So this is where the Yang for L2 stand, I guess. Thomas? Oh, next one, kid. All right, thanks. For EVPN, okay, so EVPN I think works much better. We get also the workgroup adoption since Argentina. We updated also the list of authors for the draft. So basically what we've done is we just kept the people who truly work on that draft. So the other one who did not show, who just show up once, have been dropped. So sorry guys, but I think only the people who really work should be on the list. We added also the opera data, statistics, and a few cosmetic changes. So for EVPN, we are very close to be done. Very, very close. So I'm expecting even maybe last call very soon, right? I think there's few more small details to make sure that it's going to be good, but we are pretty much done. I think there's two questions I think that came to my mind was the and we need to check with the other Yang models or other teams where we do have some common BGP attributes, and this kind of a container which has been declared on the EVPN, L2VPN, L3VPN. I think this can be something we can take it out from the current proposal because it's really a common piece. So we can maybe have a small common Yang just with that. And we do have also on the operational data, you will see that we start displaying all the routes. Personally, I'm not sure if that belongs to VPN or more to a BGP Yang model. So that's the two questions I think pending in my head. So next, please.
So the last point you mentioned is worth trying to coordinate with IDR.
Yep. Okay, so yeah, okay, so for the, sorry, this is, all right, so still again, keep up on the feedback. We need also to make sure that we cover the latest stuff we are doing in EVPN, like the flexible customer service, and maybe some RPC notification, but I think there's nothing much there.
Just a side note on this slide, the flexible cross-connect service is being proposed today, exposed today.
Yes.
It's not yet adopted, so we've been discussing this with my co-chair, and we would like you to consider, well, checking that an augmentation of the actual model for other proposals, including this one, rather than trying to fit everything in the first data model.
Okay. Yep. All right. So next one, please. Okay, this is a two open question I mentioned. Sorry.
One quick comment. If with respect to the FXA, if it is straightforward to incorporate it, given that even though it is version 00, already multiple vendors are implementing it already. And
Okay.
they're in the very close sync among ourselves.
Okay, we can reconsider, but as a matter of principle, it wouldn't make sense to incorporate into a working group data model something that relates to something that's not even adopted yet. But if it works out this way, then fine.
Just a quick comment on the flexible cross-connect service. I do have a comment, but I just wanted to wait until the presentation. But since it came up, I'm just bringing it up. I believe that I think in that draft, I mean, it's very useful. I think definitely I support that draft. But I think they're proposing the concept of a service tunnel, which in my opinion actually applies to even the existing model. So I think that is a significant change from the because it's like a user visible thing because you're associating multiple AC with the so I believe that that notion should actually exist even in the existing, because that to me looks like a pseudo kind of concept, right? Which didn't exist before, but actually we were searching for something, a hook to do on the network side. So I wanted to wait, but since this came up, I'm just bringing it up here now.
So question for you, Takar. I think maybe we should check the current Yang proposal if it does fit for EVPN VPWS. If it does, FXCs come for free.
Because I think that concept even applies to multi-point service as well, because basically that is representing actually to me is just a label right on the network side. So that is sort of actually like a pseudo kind of thing. I mean, I'm just using an analogy, okay? So to me, this is actually applicable to all the services in my mind.
And you are right, Iftikhar. It is applicable to other services. It is basically a service already in the EVPN baseline. And we have a concept of VLAN aware bundle service in the EVPN baseline. And because there wasn't any need, or at least we didn't identify any need for EVPN VPWS, we didn't carry that over from baseline to the VPWS. But then several service providers saw a need for it, and we are putting it in the EVPN VPWS as a result of this FXC. So the concept is already there in the baseline.
True. I mean, I think the concept is implicit.
No.
So now I think it's actually very explicit now. So I think that's a big difference. To me, this is a change in terms of, okay, so that's.
So we have some work to look on that, right, to make sure it's covered.
Okay.
Cool. Keep going. So those are the two questions I just mentioned about with the BGP folks. So we need also to have a discussion with IDR folks, as you mentioned, Thomas. So the next, sorry.
So one comment on this one. On the BGP command parameters, we certainly need to work with IDR again on this.
Mhm.
I don't know if some parameters are common to many Bess specs, they may be also common with other BGP specs. I don't know. I'm thinking about extended communities, for instance.
Maybe I can go on the list for that, on the alias.
Sorry?
I can go on the alias for that, on the IDR alias.
Yeah.
Okay, so for the L3 VPN, there's nothing much that happens since Argentina. I think we had only few discussion, and the routing models has changed. So the routing instance module has changed, so we need to align with it. But nothing much has been done from that side. So that's pretty much what we have for the update.
Yeah, so on this one, since the team is in place and we think we can adopt it early, even before it's considered finished or mature. So we probably call for adoption soonish.
Yep. I think the last comment I have is, I think there's been a discussion during NetMod where we need to rush or push faster our Yang model, right, overall in IETF. So if you have any comments or idea how to do that, you're welcome.
I mean, ideas on how to go faster? Just go fast. That would be good enough. No, well.
Anything that can help, basically.
Yeah.
Just a quick comment on the, I mean, as a co-author, I'm saying it would be a good idea actually to also have some examples, at least cover some of the use case configuration example, complete, like one of the use cases, to show how it will work. Pick up, yeah. In the appendix, yes, fine. So I'm saying is to actually show the model being proposed, how it will work. It could be any use case, whatever, at least one or two basic use cases. We're showing it the complete, like the access side, the BGP, I mean, like the complete pieces. All.
So you want an example with all the models?
We need to move the discussion to the list because we are too late.
Quick comment with respect
No,
to the use cases.
sorry, Ali. No, we are too late.
Okay. All right. Why don't you do it?
Thanks.
Thank you, Patrice. Next speaker is Jorge.
Good afternoon, Jorge Rabadan, Nokia. Short presentation. So this is just to call everyone's attention about this draft, because we think it's a very important draft for data center interconnect, and it's very close to last call. So just basically wanting to raise awareness of it again, and please, if you have comments, just throw them to the list. So very short refresh. So when you want to interconnect EVPN overlay networks, there are two main models at the moment. So the first one is on the top of the slide, And that's basically when you want to interconnect EVPN overlay networks to the WAN and to other networks without a gateway. That is basically specifying the main EVPN overlay draft and complemented with a new draft that Jacob is going to present today. And then when you want to interconnect EVPN overlay networks using a gateway, then you have this draft. And this draft allows you to have basically flexibility. You can connect EVPN overlay networks to different technologies in the WAN, no matter if they are VPLS based or EVPN based. Next slide, please. So what's new in this revision of the draft? So basically, we clarified the use of the unknown MAC routes. So in the cases where you have a fully virtualized data center, and you can make the assumption that the unknown MAC addresses are only existing beyond the data center gateways, you can actually use this unknown MAC route. And that is basically allowing you to not to propagate all the MAC routes that you receive from the WAN. So you may receive thousands of MAC routes coming from the WAN, but basically from the data center gateways towards the data center, you can just send a couple of unknown MAC routes. In this revision, we are allowing also to tag the unknown MAC routes with the Ethernet segment identifier, so that you can also do things like aliasing to the data center gateways for unknown traffic. We also included some other minor changes that you have here. Next slide, please. But the main idea is that we will incorporate some changes that we discussed this week. That will basically means that we will submit a revision 4 in the next few weeks. And basically with that, the draft will be ready for last call review. And so that's pretty much. So if you have comments, please let us know.
Thank you. Next speaker is Ali.
Lucy Yang from Huawei. So for your gateway solution, possible go back to his slides. Just the figure to showing previous one. Go back one, yeah. For your bottom solution, that's just have gateway. Then you have this the tunnel stitching, but actually the mechanism is that you're still doing this warp table lookup for the MAC address lookup.
That's correct. Yeah.
Okay. So we just proposed some of the new solution. But actually, we're proposing the MVO3 it's just possible to doing this tunnel stitching instead of avoid this local MAC address lookup. So maybe something we consider because that will be improve this the overlay traffic performance, reduce some delay something. Just want to not for your saying, just to let the people knowing where also propose this kind of a tunnel stitching to as the solution.
Okay.
Are you talking about the interiors option, V? Stitching?
I think she's talking about a different draft.
So where does the tunnel stitching comes into the picture in the gateway? Because when we talk about tunnel stitching, typically that's ASPR, not the gateway. Gateway, by gateway we mean looking to the MAC address or IP address. So you're saying not look at the MAC or IP address, just look at the MPLS label.
And do stitching?
Right, and then do a stitching. That's the no, that's interiors options. Okay, option B, which is describing EVPN overlay draft. If you take a look at the EVPN overlay, it talks about interiors option.
That will be the upper part of the slide.
I'm talking about layer 2 option, but not layer 2. So take a look at it.
Sure. Thank you for that information, but yeah.
Just quickly, make sure the draft is taking care of what we discussed about the orphan port hanging off the gateway, right?
Yeah, that's basically the main thing that we need to change or update. Yeah.
Well, the procedures already covers it.
Yeah, we just need to clarify.
Okay. Okay, this slide is about the one flavor of the EVPN VPWS that we didn't cover in the EVPN VPWS draft, which is going through the working group last call. And if you look at what we cover in that baseline draft, we covered these three different interfaces: VLAN base, VLAN bundle, and port base. What we didn't cover is VLAN aware bundle, which is already, it is in the RFC 7432, the EVPN baseline. But we didn't see it at that time. We didn't see a need to put it in the EVPN, to carry it in the EVPN VPWS. And it seems like the need got identified later as a result of some of the use cases. And if you go to the next slide, let's go to the next slide. It talks about the need, why we need these new flavor, okay? The reason we want it is to be able to, currently, if you look at what EVPN VPWS does, it provides a point-to-point EVC or connectivity between two attachment circuits. Whereas now we want to be able to multiplex a bunch of these ACs across different ports into the same service tunnel. So this multiplexing was or is important to some service provider to use as few as pseudo wires. We don't call pseudo wires or we don't use pseudo wires in EVPN VPWS. Instead, we are calling it service tunnel. So whenever you come across the term service tunnel, is equivalent to the pseudo wire. So the idea is to multiplex a bunch of ACs across different ports into the same service tunnel, and also at the same time reduce the BGP signaling as much as possible, so we don't have to signal on a pair attachment circuit when you do these muxing, and be able to support all those goodies, all active and single active multi-homing. It seems like this is ideal, but we cannot do, we cannot meet all those requirements. Some of them are conflicting, and mainly number 2 and number 3 are conflicting. You cannot reduce BGP signaling if you want to multiplex a lot of ACs at the same time, have all active multi-homing. Next slide. So with the flexible, again, this with the flexible cross-connect service, these are the 3 use cases we've identified, and the first one is basically talks about there is, as you can see, there is no multi-homing involved in here. We are just multiplexing bunch of attachment circuits from different ports off of PE1 into the same service tunnel. Okay, so that's scenario 1. When there is no multi-homing, then you don't need to signal these individual VLANs, whether you call it attachment circuit or VLANs, they are one of the same. There is no point in signaling them, okay? Or there is no big incentive to do it. So the default is not to signal the individual VLANs, and you can multiplex it all like that. And what this requires, requires that because you're multiplexing a bunch of VLANs into the same service tunnel, in the egress, when you want to go into the, when you want to forward the packet, in order to know which port to go to, the service label is not enough to indicate which port to go to. You now need to look at the vid in the packet, and to make sure that we have every PE has a consistent view of the vids, you do vid normalization, which means you translate it into the same space among everybody. So this is the case for single homing. Now, we had a discussion, interestingly enough, yesterday, and one of the co-authors was saying that, oh, why don't we signal the VLAN for this case as well? And as an option, we're going to put it there. And the incentive or the reason for that is so that if there is a failure via the signaling in BGP, you can make sure that the other end stops sending the traffic for those failed VLAN, and save a little bit of bandwidth in the network, because eventually if you don't do that, eventually the host's gonna stop, they're gonna time out, and they're not gonna send traffic anyway. So this is a bit of, and that part is gonna be already covered, so we get that for free in the next slide. So the next slide is multi-homing scenario, and you want to multiplex a bunch of them into the same service tunnel. And when you multiplex a bunch of VLAN into the service tunnel, then you need to signal those VLAN. So this case, you can think of the signaling the VLAN for single home as a degenerate case of this case, of this use case. This use case already covers. And in this case, you have to signal the VLAN. And the reason you have to signal the VLAN, because if one of the port fails, let's say in this case, we have CE1 and CE2. From CE1 is dual home to PE1 and PE2, and one of the port from CE1 to PE1 has failed. You need to be able to, you need to signal it to PE3 so that the PE3 send the traffic via the other service tunnel. That so for multi-homing, the signaling of the VLAN is basically a must. If you want to aggregate everything into a single service tunnel. Now the next case, did you go to the next? Okay, very good. The next case, it says, okay, at the expense of creating more service tunnel, I can get by without signaling VLANs over those service tunnel. And this use case, as you can see, in the previous use case, I had a single service tunnel between a pair of PE. Now I have two. So I have one per bundle, and instead of two, you can end up with many, depending on what possible destination they need to go to. So the advantage of going, or the trade-off of going this route is you don't have to, you're going to cut down on the signaling, BGP signaling, but at the expense of creating additional service tunnel. And again, if there is a failure, you're going to rely on the application timeout. Okay, next. The BGP extensions, we taken the BGP extended community already that we already have in the EVP and VPWS. We added two more fields. One of the field called mode M, and that specify whether it is what kind of the VLAN aware mode it is, whether what kind of the FXC mode it is, whether it is VLAN aware or VLAN unaware. And then the other field is V, regarding what kind of the VLAN ID we expect, whether it should be a single vid or double vid or what. I think that's about it. If you go to the, yeah. So
just a quick question. In the use cases, you have shown all the use cases we have shown 2 ports, but I mean, this also should apply to a single port. I have multiple VLANs.
Single port was a first use case.
Oh, single port issue, okay. Maybe.
Yeah, single
Single
segment.
port, I'm just have multiple VLANs, I'm just carrying.
Exactly.
Okay.
So that is basically the default case. You have to support it anyway. The multi-homing case is a challenging one.
Okay, just to have an idea, who has read this draft?
Okay, if you turn around, you can see me raising my hand.
Okay, thank you. Next speaker.
Sure.
Next speaker is Jacob. No, it doesn't work.
Hi, I'm Jacob Heitz from Cisco. Next slide. When we do EVPN with the EtherAD routes, the EtherAD routes have the same next hop as the MAC routes. That's how we know where they came from. Next slide. So with that, when we have a failure on one side, the EAD per ES is withdrawn. And we know that by the next hop is the same as the MAC route, so we know which MAC route to mass withdraw. Next one. Same on the bottom, so we know which one to withdraw. Next slide. Now the problem happens when we have inter-AS option B. The ASBR rewrites the next hop, so now the next hop points to the ASBR. So now all the next hops are the same. So what happens now? When we have the failure, the Ethernet per ES is withdrawn, but it has the same next hop as the other one, so we don't know which one failed. What did I write down there? Oh, okay, that was that's. So if they're not, so we could make a different rule, but we decided to make this rule. That means we withdraw nothing until everything's failed and all of the Ethernet per ES have been withdrawn. Next slide. We have a possibility of using the EAD per EVI to mass withdraw the MAC route instead. And we can do that if the EAD per EVI is actually sent. Now, because it's optional, it may not be sent. Now, we can know that if it was actually sent in the first place, thanks, AC. Okay, where was I? So if it was actually sent, then we know that, so we can use it. We can use it if it's withdrawn. So we'd have to make sure that it was actually there and withdrawn before we can use it to do the mass withdrawal. The way we do the mass withdrawal is we look at the RD. The RD must be the same as the MAC route. Next slide. Okay. The answer to that is we must add a new PE of origin. So we add the PE of origin, and that thing carries through all the way. So now we solve the problem. Now, that is not Spanish, as I was made aware of after I invented it. So the ASBR, actually, any router that changes the next hop to itself will add this PEO and copy the next hop, the received next hop, into the PEO. Now, where to put this PE of origin attribute? We found a semi-good home for it. in the tunnel encapsulation attribute, we add another TLV, although this is not really a tunnel, but we can add a TLV and put this into the remote endpoint. We need to have the IP address of the PE of origin as well as the autonomous system number, because it is possible in data centers for the next hop IP addresses to be duplicated in another AS. And that was it. Any questions? Did I go over my 10 minutes? Oh.
So who is setting the PO? Is it the ASPR or is it the origin, the egress PEs?
The first router that changes the next hop. This might be a route reflector or an ASPR.
Yeah. Thanks.
It could work either way, actually.
Okay, thank you. Can we have an idea of who has read this draft? Thank you. And next speaker is Jeffrey. No, who is it? Sorry. It's Jorge. Thanks, man.
So this draft is PBB VPN ICID based CMAC Flash, and this is the list of my co-authors. Next slide, please. So when you have PBB EVPN and you have a single active multi-homing, you need a CMAC Flash, right? And this is because the CMACs in PBB EVPN are still learned in the data plane and they are subject to aging. And as such, you need when you have a failure at the access, you need an explicit mechanism to trigger this CMAC Flash notification. So in RFC 7623, we have a CMAC Flash mechanism for a single active multi-home non-zero Ethernet segments, but it's not covering all the use cases. For instance, here in the diagram, we have a case where in the access networks, we have a different admin service providers, and basically they are using their own redundancy mechanisms, like, I don't know, active standby pseudo wires or G8032 Ethernet protection rings. And basically the connection to the core PBB VPN core network is done based on null Ethernet segments. So this is one example why we need basically in this use case we need a CMAC Flash, which is not covered in the main RFC. So the requirements that we had to address with this solution, you have a list here. Basically, it has to work independently of the Ethernet segment, and just like here in the example with null Ethernet segments, it has to provide a CMAC Flash notification at BMAC and ICID granularity. It has to be enabled or disabled on a per ICID basis. It has to be able to coexist with the existing RFC 7623 mechanisms, and be able to work with EVPN route reflectors. Next slide, please. So the solution is, well, the idea is, in this example, you have a PBB VPN network. So on the left-hand side, you have, for instance, a G8032 ring. And here in PE3, basically, you learn a bunch of CMACs from the PE1 BMAC address and for ICID1. So if you have a failure at the access, what you want is P1 should be able to trigger a CMAC Flash mechanism so that P3 is able to flash the CMACs corresponding to that BMAC and ICID, right? and without any impact on the rest of the ISIDs, basically. So what we do is, based on the access failure, or based on the MAC flash notification that you get at the access through G8032 or active standby pseudo-wire status bits, basically you trigger a BMAC route, update, where we encode the ISID in the ether tag, which is the natural place to encode the ISID. And we send that with the MAC mobility extended community with a higher sequence number. And we can reuse the mechanisms that we have in 7623 to auto-derive the route target from the ISID. And the reason why we can do that is because in that case, if we send these updates with an ISID-based route target, then the route reflectors, if we enable route target constraint, we can actually filter the updates and only send them to the P's where the ISID exists. So that's basically what we do in P1 to notify the MAC flash. And then again, the route reflector, for the route reflector is just a BMAC route. So any EVPN route reflector should be able to reflect that. And then at the reception, basically what we do is, based on this update, we will flash all the CMACs corresponding to the indicated BMAC and ISID. And yeah, the receiving Ps, they still have to comply with the RFC 7623. So no changes. The only addition is that they will look at this new BMAC update, and we'll be able to do this CMAC flash, ISID based. Next slide, please. So the conclusions, basically this mechanism is, this document is meant to be like an extension to complement all the use cases that we are missing in the main RFC. Solves the black hole scenarios independently of the Ethernet segment definition, flashes CMAX at BMAC and ISID granularity, and coexists with the existing PVV EVPN procedures. And we are requesting some feedback from the working group.
So basically, we want to do CMAC flushing on a per ISID basis.
And per BMAC.
And a per BMAC. So if you look at the baseline RFC PVB EVPN, it allows for the route type 1, the ether tag says to
route type 1?
For the BMAC, route type 2, for BMAC advertisement, it allows for it says, you know, the ether tag ID to be 0 or max is, or max, or other values are invalid. So in here, the proposal is to add ISID in there, and as a result, generating a new route, you know, for that. Why not just simply send the existing mechanism, but send it with the RT that is auto-drive based on the ISID? That is much simpler.
Yes and no, because you still need an indication of the ISID that you want to.
Well, you send it over the MAC flushing in the baseline. You send it with the mobility flag set to indicate that you need to flush.
Yeah.
In the baseline, you send it is a flush, but the RT is the RT of the EVI that says flush for all the ISIDs across all ISID for that BMAC. If you send it only with the RT of the ISID, it means only flush for that ISID on that BMAC. And that becomes really consistent with the baseline.
If you send it, yeah, if you send it with that route target, yeah, it only reaches the places where you have those ISIDs.
Yeah.
Yeah. The only thing is you're lacking an indication of the ISID itself in the route, right?
Yeah, and well,
So,
the other advantage, it is completely consistent with the baseline. So I agree we need the flushing on a per ISIT. So I agree with the motivation. Frankly, I don't like the proposed solution because it says, initially I'm gonna send it with the Mac mobility incremented, and then later I'm gonna withdraw it, you know. Whereas with this approach, we're gonna keep it consistent. You always send it with the flush indication.
But you still, if you don't include the ISIT in the route, you still, even though you only make that route and get to the places where you have that ISIT, you are still flushing for other ISITs in those.
No, because you're going to tell it only flush for that ISIT. The ISIT is already.
But the way to tell it is to put the ISIT in the route somehow, right?
No, we can. The RT information gets passed to the place that it needs to process it, so it knows, okay, I'm getting that RT.
Would you be okay to carry on the discussion on the list?
Sure.
Yeah, we need more discussion.
It seems like a discussion that would be easily pushed to the list.
Thank you.
Greg, you're the next speaker.
Okay. There was an earlier attempt to do BFD for EVPN over some time, and somewhat little different group of authors got together with a new proposal. Can we go to the next slide, please? So what are requirements? We want to detect, monitor P nodes for all the types of traffic. It's a unicast, and it's a broadcast and unknown unicast, BOM traffic. So that includes point-to-point OSP, multi-point-to-point, and point-to-multipoint OSP, as well as a multi-point-to-multipoint. In the current version, we propose only address multi-point-to-point and a point-to-multipoint. Next slide. So the original was thought in the earlier work that to use encapsulation, and then encapsulation will do demultiplexing of BFD, identifying what is being monitored. Alternative proposal in this draft, next slide please, uses approach of generic associated channel, where you can have a channel, OEM channel, for different purposes. One of the prototype is connectivity verification has been done in MPLS-TP, where it uses BFD and provides the source map ID. Very similarly, in this document, we propose to introduce two new associated channels. Code points will be allocated through IANA, and after BFD control packet, it follows with EVPN max sub TLV. And the next slide, or alternatively inclusive multicast TLV. So for that, there is a some new challenge, because if we are not using any form of IP encapsulation, then their BFD, this is a BFD asynchronous, and if we need to do communicate out of band to the PE, so how to bootstrap, how to identify their IP address of the source. That would be addressed in the future versions. It's a sort of the BFD bootstrapping problem. It could be done through LSP ping, and then the source ID of LSP ping will be identifier of their remote BFD speaker. This work was presented earlier this week in the MPLS group, and tomorrow it will be brought to attention to BFD working group. What would be interesting to get your opinion is where you think that the main work should be done. Is it the Bess group or BFD group? Because effectively we are defining quite a lot of new BFD related constructs. Next one. Yeah, as I mentioned, there is a whole list of things that we're planning to work on. It includes PVB, VPN, and it includes multi-point to multi-point, as well as addressing questions of bootstrapping BFD sessions. Yes. Any order?
All right. Jorge Rabadan, Nokia. So regarding what working group, I don't have really a strong opinion, but this working group should be made aware anyway,
of course,
of the outcome. And can you go to the slide where you have the packet format? Yeah, one more, the unicast. Because I don't know if there is a mistake, or the one before, where you have the table. Yeah, you're showing here the entropy label below the EVI label. Shouldn't be in between the transport and the EVI label. I mean, this is it's a mistake, right? It's not. Yeah, it should be swapped.
Oh, okay, yeah.
Not.
Yeah.
Okay, it's not on purpose.
No.
Okay, cool, thanks.
No, it's just an indicate that basically they're varying entropy label. We can explore available paths.
Wim Hendricks, Nokia. With respect to the bootstrapping, I would also like to see the option what we discussed before with multicast VPN to actually use BGP as a way to bootstrap the BFD session. Because I think given EVPN, the whole promise was to leverage BGP as much as we can.
Right,
so
yeah, actually, yeah.
That.
I think that, well, again, what was discussed earlier in a fast failover, that's an interesting idea. But again, I would like it to have this discussion at BFD group too, because we need to balance to make it language such that there is no race condition. So basically, if one method is selected, then the other method, how we treat if there is an attempt to do LSP ping, or if there was LSP ping, how we treat their bootstrapping for BFG,
right.
BGP.
Yeah. At least I think we should discuss to see that that option is viable from the BFD working group. And I think if so, then I think it would be useful to use it in this context as well.
I agree.
And then with respect to the data plane, I think what I read when I read the draft, I see there is two options for the data plane in terms of to use. So one is to leverage what was done on the extensions of LSP ping, what Ali did, plus you have another proposal with GAL and stuff like that.
Right, yeah. Actually, their idea of using ACH encapsulation with the TLV appended to the BFD came up rather recently.
Sure.
Okay, so that's why for now we're referring to it as an alternative encapsulation.
Right.
Okay, and actually there is a note that, for example, their BFD for VXLAN does not use this approach. So we are considering realigning it because we have a good overlap of offers on both documents.
Yeah, I given that data plane is always sensitive, I would prefer to optimize and come up with a single proposal, because otherwise we'll have to implement multiple
Yes,
things.
of course.
Yeah.
Yeah.
Then with respect to the work, I think, yeah, I agree with Jorge. It should be made aware here, but I think BFD can be the...
I see the BFD co-chair standing behind you.
All right.
So, Greg, I sent some comments on the
Yes,
list.
thank you.
There's some things which maybe I don't understand. When you say alternative proposal, so the first proposal, you have an IP header, and the second proposal, you don't have an IP header.
Right.
And then the bootstrapping you would be needing in the case where you don't have an IP header or you're using BGP or whatever. I think that part in the draft wasn't super clear, or maybe I read it too quickly. Okay. That's good.
Yeah, I agree. Thank you. Okay, thank you.
Okay, so we are right on time, which is completely amazing, yes. So thanks for the discussion on this last draft. We understand that we will need to talk to BFD. Well, the working group will need to talk with the BFD working group, and the chairs will have to talk as well. So I think we can close the meeting. Thanks for attending, Bess, and see you next time. Thank you.